In this video, we're going to talk about transformations of functions. And it's important to realize that we're going to do two types. One, what I call theoretic, when you're going to be given a theoretic function, f of x, and you're going to be asked to create a transformed function, g of x, and you're still going to have the theoretic function of f of x present, meaning if you're asked to reflect over the x-axis, g of x would be negative f of x. In addition, there are actual transformations where you're told, for example, that f of x equals x plus 4. And then you're told to have a transformation over the x-axis. So first, you're going to create the theoretic f of x, and then you're actually going to apply it to this function. So you're going to do negative f of x, which means negative x plus 4, and your final g of x is going to be negative x minus 4. So throughout this video, we're going to do both. We're going to start off with theoretic transformations, and then we're going to move on to actual transformations. This is an excellent sheet, and here you could see that this entire sheet here is made up of theoretic functions. Now, I don't want to focus on this yet, change to coordinate points, so I'm going to go ahead and cover that. I want to focus on the theoretic transformations with f of x only. And we're going to review all of these. You could see whenever something is outside of the function, you're dealing with vertical. Here we're outside the function, meaning outside of the parentheses. Vertical, vertical. Down here, we're outside of the parentheses. That's vertical. Here, we're outside of the parentheses, and it turns out that that's a reflection over the x-axis that we just spoke about. The other thing to note from this excellent worksheet is that when you're adding or subtracting, you're translating, otherwise known as shifting. So if you have a vertical translation or a vertical shift, we're shifting up and down according to adding and subtracting, whereas if we are inside the parentheses, we're dealing with horizontal translations or shifts, again, plus or minus. When we move to stretches and compressions, or stretches and shrinks, another word for compression is shrink, then we're going to be talking about multiplication. And we're going to review all of these in detail. Before we move on, I want to talk about the verbal description of the transformation. So for example, here we have a horizontal stretch factor of 4. As we'll see in a minute, I'm going to call this the factor of guy. It's important to recognize that this descriptor, stretch, has to be associated with a factor of guy that's greater than 1. And that makes sense. When you're stretching something, you're going to be multiplying it by greater than 1. And that's true whether you're in the horizontal or vertical direction. Next, we have a vertical shrink. Again, this descriptor is going to be associated with a factor of guy that's less than 1. Because when you multiply something by 1/2, you're going to shrink it. And that's true whether you're working in the vertical or horizontal direction. So here we go. Two more examples. We have a shrink. It doesn't matter if it's horizontal or vertical. When you see the word shrink, this factor of guy has to be less than 1. It has to be a fraction like 1/4, 1/3, 1/2. And finally, when we have the word stretch down here, the factor of guy has to be greater than 1. So for example, if you find yourself writing an answer that says vertical stretch factor of 1/2, then you got to go back and regroup because you've done something wrong. Because that descriptor stretch does not match with a fraction less than 1. Let's look at our first example. This is a theoretic transformation, meaning if we're given f of x, the new transformed function is f of 1/4 x. First thing you do is you recognize that this factor is inside. So this is an inside guy. Whenever you have an inside guy, you're going to be dealing with horizontal stretches and shrinks. So let's go to our word bank and pull out the word horizontal. Okay. The next thing is we're going to take factor of guy, and the way we're going to figure out factor of guy is we're going to take inside guy and we're going to move them to factor of guy, and we're going to do a reciprocal. So he becomes 4. Finally, we're going to figure out what goes in this gap, stretch or shrink. And as I spoke about in the previous slide, this factor, because it's greater than 1, has to be a stretch. So in summary, this f of 1/4 x is a horizontal stretch by a factor of 4. Let's go ahead and do another one. Okay. Let's return the word bank. We're going to leave factor of guy because we're going to need him every time. Okay, we're going to change this now to 3 times f of x. Okay, now we got an outside guy. Whenever you have an outside guy, you know you're dealing with a vertical transformation. So let's bring vertical up. When you're dealing with a vertical transformation, the outside guy and the factor of guy are exactly the same. There's no reciprocal involved. Finally, if you have a factor of 3 greater than 1, this has to be a stretch. So this 3 times f of x is going to be a vertical stretch factor of 3. Okay, let's do one more. Here, we're going to do f of 4x. Okay, first thing we're going to do is we see an inside guy. That means this is horizontal. Next, we're going to take inside guy. And when he becomes factor of guy, it's the reciprocal, 1/4. Because that's less than 1, this has to be a shrink. F of 4x is a horizontal shrink factor of 1/4. Let's move on to this next example. There's a theoretic function f of x. We have a transformation g of x where we do f of x plus 4. Here, because a plus is involved, we know this is going to be a shift, or otherwise known as a translation. Okay, because the action is inside the parentheses, we know that it's going to be a horizontal shift. Okay, the next thing is we know it's going to be 4 units because we see the 4 there. The question is this going to be left, right, up, or down? Well, we know it's going to be left or right because this is a horizontal translation. Now the question is left or right. Normally, if you look at a number line, the positive side of the number line is on the right. However, when we're dealing with horizontal transformations, we're going to switch that to left. So this is going to be a horizontal shift left 4 units. Okay, let's switch it up. Okay, how about this one? Okay, we're dealing with adding and subtracting, so we know it's a shift as opposed to compression and stretch. Because this is on the outside of the function, we know that we are dealing with a vertical shift. Therefore, We know it's going to be up or down. We know the number of units is going to be 3. And when you're dealing with vertical shifts, you do exactly what you see. So when you see a -3, okay, the -3 is going to be on the left side of the number line. Or actually, a better way to think of this would be a vertical number line. Okay, so -3 would be on this, you'd go down to get to -3 on a vertical number line. So that's exactly what we're going to do. We're going to do exactly what we see, and this is going to be a vertical shift down 3 units. Okay, let's look at this next example where we have an unknown or theoretic function f of x, and we're asked to have a transformation g of x of f of 2 factored out x minus 2, or f of 2x minus 4. So very interesting. These are actually the same function, because this is, if you distribute that 2, you're going to get 2x minus 4. But the fact that this one on the left has the GCF pulled out versus this one where there is no GCF, this is not factored on the right. The order of what we do is going to change. Okay, let's start on the left. When you have your transformation in factored form with that GCF pulled out, we're going to address that first and this second. However, when the GCF is not pulled out, 2x minus 4, then we're going to do the shifting first, the translation first, and the compression or stretch second. Very important. You may want to take a screenshot of that. Okay, let's go ahead and use our word bank and figure both of these out. Okay, so on the left, we see that we have an inside guy. That is being multiplied by. That means this is going to be a stretch or a shrink. All right. The fact that we're dealing inside the parentheses means we're going to bring horizontal from the word bank. All right. Now, factor of guy is always involved. We take the inside guy, and the factor of guy becomes the reciprocal, 1/2. If this is 1/2, this descriptor has to be a shrink. They go together. Shrink and 1/2 go together because this is less than 1. Okay, that was step 1. Now we're dealing with a shift. We're still going to be horizontal because we are inside the parentheses, so I'm just going to put quote marks. We know we're going to be shifting 2 units. The question is, are we going to be we're going to be shifting right or left? -2 is on the left side of the horizontal number line. We're going to switch that and say it's a shift right 2 units. All right, so in summary, first, this is a horizontal shrink by a factor of 1/2, and then it's a horizontal shift to the right 2 units. All right, now let's do its counterpart, where things are factored. Okay, I'm never going to be able to move this stuff. Okay, now we have the inside factored. All right, so let's see how that changes things. Okay, thank you for your patience. Okay, we know we're still going to be doing horizontal work because we're inside the parentheses. But now, because this is not in factored form, we're going to be addressing the shift first. We're going to shift. Okay, factor of is not involved. We're going to shift 4 units. The question is, do we go right or left? We associate the negative sign with the left side of the number line. Therefore, we're going to flip it, and we're going to go right. So this is a horizontal shift to the right 4. Now we're going to address this. This is the inside guy. He's 2. That means the factor of guy is going to be the reciprocal of that. So the factor of guy is going to be 1/2. The fact that that is 1/2 means that this descriptor has to be a shrink. So part 1 is a horizontal shift to the right 4 units, and part 2 is going to be a horizontal shrink by a factor of 1/2. Whenever it's factored, whenever the GCF is pulled out, you do this first, that second. When there's no GCF, you do the shifting first, and then the shrink or compression second. In this next section, we're going to start introducing actual f of x functions, and we're going to talk about the transformations thereof. This first function, the parent function, is the square root of x, and this is the transformed function. Other parent functions that you're going to see going forward would be something like this, where you have something in parentheses raised to an exponent, or the absolute value function. These are examples of the parent function where what's within the parentheses, what's within the absolute value signs, what's in the radicand under the radical, these are all inside of the function. Inside in parentheses, inside within the absolute value. Anything outside of these, so if you have something out here, if you have something out here, if you have something in front here, multiplying here, outside here, all the outside numbers are going to refer to vertical, and anything inside the absolute value signs, inside the parentheses, inside the radical, these are all going to be horizontal transformations. Okay, so let's talk about this specific example where we take the parent function of the square root of x, and our new transformed function is the square root of 1/3 x plus 1. All of this is in the radicand. All of this is on the inside. Now, we have two things going on horizontally. We have a compression or a stretch, and we have a shift left or right. Which of these do we do first? Ask ourselves, is this in factored form where the GCF is pulled out? Answer, no. When there's no GCF, when we're not in factored form, we're going to address this first, the shift. Okay, we know we're inside the function, so we know it's horizontal. We know the word shift is involved because it's a plus or a minus. We know there's 1 unit. The next question is, are we going left or right? If we look at the number line, the positive side is associated with the right side of the number line, horizontal number line. We're going to switch it to left. Okay, that's the first transformation in this particular problem. Next, we're going to look at that 1/3. We know we're still horizontal because we're still within the side of the function. The factor of guy is going to be the reciprocal of the inside guy. It's got to be 3. If this is greater than 1, the descriptor has to be stretch. Horizontal stretch, factor of 3. Okay, let's move on down here now. Now we're given an actual f of x function, not theoretic, not apparent, an actual function, and we're asked to create a g of x with this transformation. Okay, so the important thing to realize, folks, right here, is that if you don't see a parentheses, then that 10 is considered outside of the parentheses. No parentheses means that's outside the parentheses. So in other words, we can rewrite this here in green as 10 x plus 0 plus 20. Outside of the function. Okay, so let's take a look at this. This is f of x. we want to create a g of x that will reveal or create this translation. All right, when you're doing these problems, when you're going from f of x in the real world and trying to get to g of x, you got to do the theoretic f of x first. In my opinion, that's much easier. Okay, so we're going to create theoretic f of x that applies to these words right there. Okay, here we go. Compress vertically. That means we are going to be outside of the function. Okay. We're going to be outside because it's vertical. Compressing means we're going to be multiplying. Shifting or translating, we're adding and subtracting. Compress, shrink, stretch, we're multiplying. Our factor of guy is 4/5. He stays the same as is. We do not do the reciprocal. Okay, so now we have the instructions turned into a theoretic transformation of f of x. Now we're just going to replace this f of x with this right here. Actually, this will be easier. Okay, we know f of x equals 10x plus 20. Our transformation is going to be 4/5 of f of x. We are simply going to substitute 10x plus 20 for f of x. Our g of x is now going to be 4/5 of f of x, or 4/5 of 10x plus 20. Okay, here in pink on the left, we're going to distribute. So this is going to be our final answer over here. G of x is going to equal 4/5 times 10x is going to be 8x. And 4/5 times 20 is going to be 16. This is our final answer right there. Next, we are told that f of x equals 16x minus 9. We're in the real world, a real world f of x function, and we're asked to perform a horizontal stretch factor of 8. First thing we do is we create the theoretic transformation that matches these words. Okay, so we have a theoretic function of f of x, excuse me, equals, okay. Horizontal, that means we're going to be working inside the parentheses. Stretch, factor of 8. Notice, these words match. That descriptor matches a factor of guy that's greater than 1. If for whatever reason your teacher asks you to do a stretch of a factor of 1/2, you're going to tell him or her there must be something, this must be a typo, because the descriptor stretch does not go with a factor of guy that's less than 1. Okay, so the factor of guy is 8. We know when we're dealing with stretching or shrinking, we're talking about multiplication. So we're going to be multiplying this inside x by an inside guy. Who is that inside guy? We're going to take factor of guy, and when we bring him inside, we're going to do the reciprocal. Okay, so it works both ways. Remember, previously we were given f of 1/4 x and asked to describe the transformation. We took 1/4, the inside guy, and we flipped him to get factor of guy. We do the same thing. We go from factor of guy to inside guy, we do the reciprocal. So this is going to be a horizontal stretch factor of 8. Okay, now that we have our theoretic transformation, we're going to take the real world and we're going to do f of 1/8 x. What does that mean? That means that wherever we see x in f of x, we're going to replace it with 1/8 x. Okay, so here we have original f of x equals 16x minus 9. F of 1/8 x means everywhere we see an x, we're going to replace it with 1/8 x. Okay, that's going to give us 16. This is now g of x equals 16 times 1/8 x, and the minus 9 is unaffected. Here, this is going to turn into 2x minus 9, and that is your final answer for g of x. Sorry, that's not very neat. Okay, down below, real world function is given, negative x plus 2. We're asked to shrink, create g of x where we shrink horizontally by a factor of 1/12. We are going to create the theoretic f of x here first. Okay, so the theoretic f of x is going to be, okay, our g of x is going to be f of something in the parentheses is going to change. How do we know? Because we're dealing with a horizontal transformation. Okay, so here's our original f of x. There's no shifting, there's no translation. So this parentheses is too big. We don't need it this big. It's only going to be something with an inside guy creating that shrink. Okay, first of all, when we look at the question, we notice that the word shrink, that descriptor, shrink, matches a factor of guy that's less than 1. When we take our factor of guy and we bring it inside the function as the inside guy, we are going to flip it. So this is going to be a horizontal shrink by a factor of 1/12. Now we're going to take f of 12x and we're going to bring this into the real world function. All right, so here's our f of x, which is minus x plus 2. Our g of x is going to be f of 12x. So our g of x is going to be, we're going to go to f of x. Everywhere we see an x, we're going to replace it with 12x. So this is going to be negative 1 times 12x plus 2. Okay, so all we did was take this 12x and put it in for x. You can imagine that there was a parentheses there originally. That 12x replaces that x. Okay, now we're just going to distribute the negative. And this is our final answer. Note that original plus 2 is not affected, because of course that negative does not apply to that positive 2. This is your g of x. Next, we are given a real-world function. F of x is negative 4x minus 1. We are asked to stretch this vertically by a factor of 3. Okay, we see the word vertical. We know that we're going to have to be adding numbers outside the function. We're going to create our theoretic transformation using f of x. Okay, so here's f of x. We know we're going to be outside. The fact that we're stretching means we're going to be multiplying. Stretch or compress, stretch or shrink are all multiplying. So we're going to be multiplying something. We're going to be putting something right here. The fact that this is vertical, our factor of guy stays exactly as is. Okay, so our g of x is going to be 3 times f of x. We're going to take our original f of x, which is right here, negative 4x minus 1. And we're going to multiply it by 3, and our g of x final is going to be negative 12x minus 3. Okay, down below now we got two things going on. All right, we have a parent function of the absolute value of x. We're going to shift it 2 to the right and then a horizontal stretch factor of 2. Both of these are horizontal transformations. If you're shifting right or left, that's horizontal. If you're doing a horizontal stretch, then obviously that's horizontal. That means when we create our theoretic transformation of f of x, we're going to be working inside the parentheses. Or in this case, we're going to be doing f of the absolute value, like that. Okay, actually, let's keep it f of x. I like that better. Okay, so now the fact that there's two things going on, there's a shift and a stretch. I made this parentheses wider because now I'm going to have to put two things here. All right, so here's our x. Okay, we know we're going to have an inside guy and then we're going to be adding or subtracting something over here to reflect that shift. Okay, now, folks, remember, if you're shifting first, then stretching or compressing, that means we are in non-factored form. So we're going to address this first. There's going to be no GCF. Okay, so we're going to do this first. What's going to go here? Or if we're shifting 2 to the right, you know there's a 2 involved. Now, the question is this a plus or a minus? When we think of the right side of the horizontal number line, we think of plus. When we move it into our transform functions, we're going to change that to minus. Okay, let's now move to the stretch. All right, first, notice the word stretch, the descriptor stretch, matches a factor of guy that's greater than 1. When we bring factor of guy in as inside guy, we're going to do the reciprocal. So that's going to be our transformation. We're going to do f of 1/2 x minus 2. So let's go ahead and do that. Everywhere we see f, here's f of x down here. Let's bring it down here. F of x equals the absolute value of x. G of x means everywhere we see an x, we're going to replace it with 1/2 x minus 2. And folks, that is your final answer. Next, we are given a real-world function of f of x equals x. We're asked to shift 3 units down and then do a vertical shrink of a factor of 3. So very interesting. We're doing both vertical transformations, so we're going to be outside of the parentheses. So let's do our theoretic transformation first. Okay, so our g of x is going to be f of x with a couple of things going on the outside. Okay, so if we're going to go 3 units down, it's going to be f of x minus 3. Then do a vertical shrink factor of 3. And of note, the word shrink, that descriptor matches the factor of being less than 1. Okay, so here, folks, first we're going to do 3 units down. Then we're going to take this new function. If you want, you can call that h of x and shrink it by a factor of 1/3. So we're going to do this. 1/3 of this temporary function, h of x. Okay, so 1/3 f of x minus 3. Okay, now everywhere we see f of x, we're going to put x. So we're going to have final g of x is going to equal 1/3 of x minus 3. And when you distribute that, you're going to get 1/3 x minus 1 as our final answer for g of x. Okay, moving down, we have a vertical stretch of a factor of 2, then shift up a unit. All right, here's our original function. Let's do our theoretic g of x. Okay, so vertical stretch, we're going to have f of x, factor of 2, we keep it as is. Then we shift up 1 unit. Okay. We're going to take f of x, which is just x, and replace it. We're going to have 2x plus 1 as our final g of x. Next, we are told that g of x, which is a transformation of the parent function, is shown here. The parent function f of x was the square root of x, and we're asked to describe the transformations that occurred in order. In this scenario, I like to go inside out, so we're going to talk about the inside transformations that are underneath the radicand, And then we're going to move to the outside or vertical transformations. Okay, within the radicand, we see that this is in non-factored form. There's no GCF pulled out. Therefore, we're going to address that shift first. We know it's going to be a shift of 4 units. The question is it going to be right or left? We associate the plus sign with the right side of the horizontal number line. Right side plus, we're going to change this to left. That's what we do with horizontal. Okay, second, we're going to address this right here. So we know there's going to be a factor of involved, a factor of guys coming into it. We know the word horizontal's coming into it because we're inside the function. The question is that a shrink or a stretch? Well, if the inside guy is 1/2, the factor of guy is the reciprocal, which is 2, and the word stretch matches a factor of guy that is greater than 1. Okay, now we're going to move outside of the function. And when you're outside of the function, you obey the order of operations, meaning this negative is going to be a reflection over the x-axis. Now we're going to address that 3 before the positive 2 because we're multiplying. So we're multiplying, adding. We're going to do the order of operations, multiplying, adding. Okay, the multiplication by 3 is going to be a vertical stretch, factor of 3. Remember, when you're dealing with the outside guy, the factor of guy matches factor of 3, and that word stretch and a factor greater than 1 match. And finally, there's going to be a shift up, positive 2. Manifested or reflected by that plus 2. Okay, moving on down here, we have the g of x is this transformed function, which means f of x was the original floor function. Okay, or greatest integer function, or bracket function. I've heard it described all 3 ways. Okay, we're going to go inside out. We're going to look inside of that function. We see that this is in factored form. When we're in factored form, when there's a GCF pulled out inside, we're going to do that first and that second. Okay, so we know we're going to have a horizontal compression or stretch. We know factor of guy is going to be involved. Okay. Inside guy is 2. Factor of guy is going to be 1/2. Therefore, this word has to be shrink. This descriptor has to be shrink if that factor of guy is 1/2. Why is factor of guy 1/2? It's the reciprocal of inside guy. Okay, now let's move to the shift. Okay, so we know it's going to be horizontal shift of 4 units. The only question is it right or left? When we think about -4, we think about -4 being on the left side of the number line. However, we're going to change the word to right because that's what we do. So first is a horizontal shrink factor of 1/2, then a shift to the right 4 units. Okay, now let's move outside. So we're going to have this first because we're multiplying. This is going to be a vertical shrink factor of 1/2 because the factor of guy and the outside guy match, and the word here has to be shrink because the factor of guy is less than 1. And then finally, for number 4, it's going to be a shift down 1 unit. Next, we are given that g of x is what we have here, 2 minus 3 over x plus 8. And we're asked to find, or describe the transformations that led to this. So the first thing I would do here, folks, is I would rewrite this. Okay, I would rewrite this as negative 3 times 1 over x plus 8, and I put this in parentheses, plus 2. All right, this kind of elucidates what's going on here, separating things out, putting in a hidden 1, etc. Now we could see that the parent function, f of x, was 1 over x. And let's describe the transformations. Okay, we like to start inside. That plus 8, normally we think of the positive sign of the number line is on the right. Therefore, that's going to be a horizontal shift left 8 units. Okay, that's all there is inside the function. There's no compression, there's no stretch. Now we're going to move outside, we're going to do the order of operations. This is going to be a reflection over the x-axis. This is going to be a vertical stretch factor of 3. This is going to be a shift up 2 units. Okay, moving down here now, we've shifted to a theoretic function where we had an original f of x equals x, and now we have 2 times f of 1 half x is how I would rewrite that. Okay, so let's describe this transformation. We're going to go inside, then out. Inside, we see multiplication going on. That means it's a horizontal shrink or stretch. This is a factor of Guy of 2. That means it has to be a horizontal stretch. Horizontal stretch factor of 2. The word stretch has to match a factor of Guy greater than 1. And then we're going to come outside and we're going to do a vertical stretch factor of 2. Next, we're going to talk about moving points during a transformation. So if we're given a point that's located on f of x of 3, 1, we're going to do a transformation, g of x, and we're going to have new points, x prime and a y prime. This is totally different than everything we've done up until this video, and we're going to use these two formulas. The new x is going to be x original, so in this case that would be the 3, divided by the b value, and then opposite of what you see with the c. I've seen this as plus or minus depending on the source, but the important sign is this one here. That means whatever you see in those parentheses, you're going to do the opposite. And we'll see plenty of examples, and that will become clear. The y value is more straightforward. We're going to multiply the y value, the y original value, by a, and we're going to add d. And that's a plus, which means you do exactly what you see here. If this is a minus 3, you do minus 3 here. If this is plus 12, you do plus 12 here. And notice, the y value is affected by the two outside guys, that one, and the x value is going to be affected by the inside guy as well as the c value. Okay, now one important thing to review is when you're dealing with the new x, you have to be cognizant of whether or not you are in factored form with the GCF or non-factored form. For example, if you have this here in factored form, you're going to divide by the b value first, and then you're going to add or subtract the c. So in this example here, the first thing we would do is recognize that our b value is 3, and our c value is going to come from that plus 1. So we're going to take the original x, so in our example, that's 3 up here. We're going to divide by the b value, which is 3, and then we're going to subtract 1. We're going to take what we see, circle it, and flip it. So this is going to be 1 minus 1, which is 0. This is our new x value. However, if you're in non-factored form, there's no GCF, there's only one set of parentheses, as opposed to when there's a GCF, you're going to see two sets of parentheses. Here, we're going to address the C value first, and then the B value. So here, we're going to take our X original, which is 3, we're going to subtract 3, we're going to get 0, and then we're going to divide by the B value, which is 3, and we get the same result. Very important to look at order of operations depending on whether there's a GCF or not a GCF. Next, we are given a real-world function. The square root of x is going to be our f of x is a point on f of x. Here's our transformation, and we want to figure out where this point will be transformed to. Let's go ahead and do the x first. Recall our generic formula is our x new, or x prime, is going to be x original divided by b minus c. Now, the question is, which of these do you do first? Well, we are in a non-factored form. There's no GCF. There's no second set of parentheses with the GCF pulled out. That means we're going to address the c first and the b second. So here's our x original is 4. We're going to do the opposite of what we see is 2. That gives us 6. Now we're going to come along and divide by b, and our final x prime equals 3. Now we'll do our y prime. The y prime is always easier. It's going to be a times y original plus d. We have a hidden 1 here in front as our a value, so we're going to do 1 times 2 equals 2, and then we're going to do negative 3 equals negative 1. Recall, when you have a positive in the generic formula, a positive sign, you take exactly what you see and you utilize that. Okay, so our new point, x prime, y prime, is going to be 3, comma, negative 1. Folks, real quickly, let me show you what you're not allowed to do. Okay, you're not allowed to say, okay, well, if this is our g of x, we're going to do f of 2x minus 2 minus 3. All right, so g of x would be, we're plugging in 2x minus 2 everywhere we see square root of x, and then we're going to have minus 3. What you can't do is take that 4 and plug it in. If you did that, you would get the square root of 8 minus 2, which is 6, minus 3. The square root of 6 minus 3 is not negative 1. So you cannot do that. Why? Because the 4 is shifting. You can't plug 4 into g of x and expect to get the correct answer, because the 4 has changed to 3. Now, if you plug 3 in there, then you can get the square root of 6 minus 2 minus 3. The square root of 6 minus 2 is 4 minus 3. And we're going to get 2 minus 3 equals negative 1. That you can do. So once you get your x value, you could theoretically plug that new x value into the new function, transform function, and get the correct y value. Next, we are given a theoretic function f of x, and we're told there's a point 5 comma negative 3 on that function, and we have the transformed function g of x, which is f of 2 minus x plus 7. Folks, the first thing I would do here is I would rewrite g of x into something that I'm used to seeing more frequently. So I would pull out a negative 1, which is a GCF, then I would have x minus 2. Okay, now I always go back and redistribute and check when I do that. So negative 1 times x is negative x. We had negative x originally. Negative 1 times negative 2 is positive 2, and we had positive 2 originally. And let's not forget our plus 7. Okay, folks, we got a GCF here. That means we're going to do that first and this second. All right, our new x is going to be x original, which is 5, divided by the b value, which is negative 1. That's going to give us negative 5. Then we're going to do the opposite of what we see here. So we're going to add 2, and our final x is going to be negative 3. Our y value is always easier. We're going to do y prime is going to be equal to the a value, which is positive 1, times y original, which is negative 3, and we're going to do exactly what we see, which is add 7, and our new point is going to be negative 3, comma 4. Next, we are given a 0.5 comma negative 3 on a theoretic function f of x, and we're asked to find that point on this new transformed function g of x. Okay, let's start with our x. We're going to have our x prime is going to equal. Okay, now look, we are not in factored form. There's no GCF. There's no second set of parentheses. So we're going to address this first, and then that second. Okay, first thing we're going to do is do the opposite of what we see. We're going to take our x original, which is 5, and instead of subtracting 1, we're going to add 1, which is 6. Then we're going to divide by our b value, which is 3, and our final x prime is going to be positive 2. For the y value, we're going to take the y original, which is negative 3. We're going to multiply it by the a value, which is 2. That gives us negative 6. And then we're going to add the positive 4, and we're going to get negative 2 as our y prime. Folks, at the conclusion of the video, I just want to show you another method of doing this. And if you find this easier, feel free to give it a shot. Okay, same problem that we just did. We know this is our final answer. Well, let's see if we can do this a different way. We're told that f of x is a 0.5 comma negative 3. That means by definition f of 5 is going to equal negative 3. Okay, we're going to use this. Alright, first thing we're going to do is we're going to take what's inside the parentheses here, this entire expression, and we're going to set that equal to the original x, which was 5. We're going to solve for x. Folks, that is our new x value. Look, it matches what we got previously. Okay, then what we're going to do is we're going to do g of the new x value. Okay, so g of the new x value is plugging in 2 everywhere we see an x. So we're going to have 2 times f of 3 times 2, that's plugging in the new x value, minus 1 plus 4. 2 times f of 6 minus 1 plus 4. 2 times f of 5 plus 4. But folks, we have f of 5. It's right here. So we're going to substitute f of 5. We're going to substitute negative 3 for f of 5. We're going to get 2 times negative 3 plus 4. That's negative 6 plus 4. That equals negative 2. Let's use that new technique on the problem that we did a few moments ago, where we know the answer was negative 3 comma 4 for our new point x prime comma y prime. First thing we're going to do is recognize that f of 5 equals negative 3. We are going to use that later on. Alright, so the first thing we're going to do is we're going to take what's in this parentheses, 2 minus x, and set it to the original x value, which is 5. That's going to give us negative x equals 3, and x equals negative 3. Folks, that is your new x right there. Now, to get the new y, our y prime is going to equal g of the new x, which is negative 3. So we're going to plug in negative 3 into g. So that's going to give us f of 2 minus negative 3 plus 7. It's going to equal f of 5 plus 7. Folks, we know what f of 5 is. F of 5 is negative 3. Negative 3 plus 7 equals positive 4, and that matches.